Bismillahirrahmanirrahim. So today we will continue from the rotating axis, and we'll do another example. So this is an example where we have a bar. This is a bar pivoted at one end. There's a pin there, and there's a collar, and at the same time there is a pin on the collar, and this is also connected to another bar. This bar is also pivoted at one end, and they are all connected to a vertical wall. And then let's call this point A, and point C is on the pin, point C, and this is bar AB, and this is bar DE. So this collar is moving, allowed to move left to right. At the same time, this angle is 45 degrees, and we have the distance from A to D as 0.4 meter. 0.4 meter, and from D to C is also 0.4 meter. So this is 0.4 meter. And for this given instance, bar AB is rotating at the speed of, and it's given here like omega AB equals to 3 radian per second, and it's also accelerating alpha AB at a rate of 4 radian per second square. So when this bar AB move this way, it will pull the pin C this way, and at the same time will push the collar to move along DE outwards. Yeah. So the question is, so this thing will start to move and have acceleration. Yeah. So this will have omega DE, and this is alpha DE. And the question asks us to determine the angular speed of the link DE, and also the angular acceleration of the link DE. So that was the question. So what do we do? And the question asks us to use a coordinate system. In this case, they ask us to use, this will be our big X, which is, and this is the capital Y. That is the global system, and also it has to coincide with our rotating system X and Y. So Y and X coincide, but X small will rotate together with link DE. So we will see that here that XY will rotate with DE. Yeah. So there are two equations that we need to use. First, let's list down the equations that we have to use. The first equations are the equations. The first one is the velocity. So V of C, the velocity of C, is equivalent to V of A plus A is the origin of this, plus omega cross R. I'm using the initial formula and V relative. Okay, and there's another equation, which is the acceleration. A of C equals to acceleration of the origin AA plus A relative plus omega dot cross R plus 2 omega cross V relative, all vectors. And finally we've got plus omega cross R. How do we then solve, how do we relate this equation? Remember, this equation we obtained from our derivation, and how do we relate to this kind of scenario? How do we then map these two solutions together? So we need to know how these things are, these things are connected or related to each other. So the first one is look at the what is the. So I will try to link with you, yeah. So VA is the speed of the origin of XY. Omega is related to the rotating axis, so we want, so XY, small xy is rotating with DE, so it will be omega DE. Position vector R is where the C is located on the rotating axis, so it's 0.4 meter from the origin, so this is 0.4 I. Okay, and the V relative is the speed of C relative to DE. So then we know that the relative speed is the collar sliding along DE, so we know the direction already, so I can quickly put that in the I direction. Yeah, so that's how I map the system. And what is AA? AA is the acceleration of the origin. Again, the same thing, acceleration origin of XY, which is here. And in this case, the A is 0. Of course, origin XY is not moving, so it's 0. And then A relative is similar to concept of the V relative. The collar can only slide along DE, so we can now put A relative I, because it can only move in the I direction. Omega dot is what is the omega dot is the alpha DE. It is how fast the XY is rotating, or what is the acceleration or angular acceleration of XY, the small rotating axis. R, we know what R is. It's similar to that, 0.4 I. We know what omega is. We know what V relative is. It's already there. And then everything else is defined. Once we have defined everything, it's easy or relatively easy for us to carry out the work. Do we know what VC is? VC is not similar to VB. VC is not similar to, we cannot say VC is the pin move. So VC is also restricted to move along DE, so we can put that as VCI. No, VC, we can calculate VC. I will show you how to calculate later on VC. And AC, we can also calculate AC. So the trajectory of VC and AC is that point C, we must know where point C is. Point C is on the link. Which link? It will be AB. So if you know that point C is on the link AB, therefore we can find VC equals to omega AB cross vector position of C relative to A. So what is C relative to A? So it is 0.4 meter up and 0.4 meter to the right. So this is 0.4J and 0.4i. So we can say here that omega AB is, because of XY system, omega AB is minus 3k cross 0.4i plus 0.4j. Yeah. So we have the answer for that. And that is equals to k minus 1.2 kij 1.2j, and then k cross j minus I minus positive, so plus 1.2i. So that's your VC. So once we know what VC is, do you know what VA is? VA is 0. And do you know omega dE cross, let's do omega cross R. So we know that, so we can say, I'm going to do this, yeah. So omega cross R, omega, we can now say omega is equivalent to omega dE, and we immediately can replace that with omega dEk, yeah. Cross R, what is R? R is given by 0.4i, k cross I is j, so 0.4 omega dE k cross I is j, k cross omega dE j. We have solved this part. What is V relative? So I can now put, using equation of velocity, can now use the velocity equation to do that. So omega cross R, we can have this minus, so we have VC here is 1.2 j plus 1.2 I equals to 0. VA equals to 0. I'll just put 0 to make this equation complete. And omega cross R, I have this 0.4 omega dEj. And then I have V relative, so I just put it V relative I. So I can now take my J. I'm solving the J component, so it's minus 1.2 equals to 0.4 omega dE, and I can now say that my omega dE equals to minus 0.2 divided by 0.4, that's minus 3. And I can put the answer as omega dE equals to minus 3k radian per second. Okay, that's the solution for velocity. Oh, sorry. Oh, no. Okay. Oh, yeah. So this is omega cross R. We have done that before. It's minus 4 omega d. So this part is from here. Yeah. So this is VC. Again, this is VC. Let me put it in different color. So this is from VC equals to VA. VA is equal to 0. This is omega cross R, and this is V relative. Yeah. So all these terms are there, and from there we can find what omega d is. So you can try to use the same approach for acceleration.